Okay, if you go to the next slide, you will find that the design methodology for civil engineering, okay, which almost has the same steps, okay, but it includes an extra step of feasibility study. Okay, we already talked about it. So feasibility can be technical, it can be economic, it can be environmental. Okay, the feasibility study so they have a extra step there in the design methodology. If you see, the extra step is doing the feasibility study for the project. Okay, and feasibility study includes looking at the impact of the project. Okay, when we say feasibility, so I told you feasibility means, the word feasibility means looking at possibility of the project. Okay, but in civil engineering projects, when somebody says feasibility study, what do they mean? They mean calculating the impact of the project. Okay, calculating the impact of the project, and the impact can be technical impact, economic impact, or environmental impact. Okay, technical means what it will do to the client, what problem it will solve, what requirements it will fulfill, and so on. These are technical. This is technical feasibility. Okay, economic feasibility, how much cost it will have. Okay, and another aspect is economics is not only about cost. Okay, economics is also about benefits. Right? So the difference between cost and economics is, cost means what you are consuming, right? Now, economics also include what you are getting out of it. Right? Okay, and when we say the word cost, we normally mean money, right? But the cost is not only in terms of money. The cost can be in terms of what? Time, safety. Okay, these are all different cost elements. Okay, for example, if you take road projects, okay, for a new road project, you may consider the time saving as a benefit out of the system. Okay, you may consider the accidents which are happening on the road currently as one of the costs of not doing the project. But no point. Okay, so the cost, when you use the term economic feasibility, we are not talking only about how much money is spent on the project. This economic feasibility also includes other types of costs which are not money only, such as safety, such as time, such as resources, okay, and so on. And the benefits can also be in the same way. The benefits can be something you are earning from it. For example, if you build a factory, if you build a power plant, if you build an oil refinery, okay, then the benefit is what you are selling, right? Okay, or if it is a building which you are giving for rent, then the rent is the benefit, right? Okay, but there are benefits which are beyond that. For example, if you build a new road, okay, then that new road may change the value of the land. Okay, it may open up other opportunities for businesses. So that area didn't have a proper road there, so people were not going and living there. You built a new road, now people are going and living there. So when people start living somewhere, what else follows? So there was nothing here in this area. Now there is a housing project. Okay, so people will live here. So what else do they need? These people who will live in this area, they will need something else, right? What? Nothing. Huh? You need to grow up, right? that, okay, I will give you the money, you buy a house anyway. What you will look for? Huh? Facilities like
shops,
yes,
hospitals,
yes, okay. So you are not the only Einstein who is thinking about it, right? Those people who are running their businesses, they also look for these things. Okay, so they are also looking at the demand. So when you build a new road, a housing project started. That housing project is now attracting other businesses. Get my point? So this all comes under economic feasibility. This is the economic impact of your project, right? Okay. So it's not only cost, and we have already talked about lot of environmental impacts of the project. Okay. Then we have the conceptual design. Okay. So here you see in this methodology 3 types of design. Okay. In this methodology you see 3 types of design: conceptual, preliminary, and detailed. Okay. Conceptual is just like a sketch. Okay, you have very rough details, no details at all. Okay, it's just like you tell me I'm going to build a villa which will have ground plus 1, that's it. Okay, and it will have 4 rooms, for example, and that's it. So this is called what? This is conceptual design. You just have the main details, you don't know anything about the design. Okay, this is just what you want. So I need a villa which will have 1 story above the ground and it will have 4 rooms. That's it. This is called as what? Conceptual design. Okay. Then you move on to the next stage, which is the preliminary design. So it has more details than the conceptual design. Okay. But the design is still not finalized. Okay. You still do not know the internal details. This is preliminary design is just like the architectural drawings. You have seen the architectural drawings, right? Okay, the elevations and the plans and so on. So most of the structural detail is not known, even now. So the difference between conceptual design and preliminary design is now you have more details about how the project will look like. Okay, how the project will look like. Okay, so earlier it was just a sketch of what you want. Then you move on. You finalize more details about the layout of the project. About the layout of the project. Okay. Anybody taking highway project now? Highway course? You are taking now? You have already taken it? What you are doing here? Only. Okay. But in the highway projects, or even in surveying, you have seen the curves, right? Horizontal curves, vertical curves. Okay. This is called as layout. When somebody did that, I told you there are 2 lanes, each lane has this much width, okay, and it will have a curvature of this much and a gradient of this much. Can you construct the road? No? Can you do the construction of the road? People are thinking, can I do it? No, you cannot. Okay? Don't think too much. You cannot. Because still you don't know what is inside the road, right? You still don't know what type of material you use, right? You still don't know the thickness of the layers. You still don't know the slope of the sides and so on. Got it? Okay. So when you do the layout, you are at the preliminary stage. So you went from conceptual to preliminary, and then you move on to the next stage, which is the final design, detailed design. Okay. Now you know inside what is happening. Clear? So in the detailed design, final design, you are looking at the inside of the structure. Got it? Okay. Then we have the construction planning, where you plan what you will need, when, at what time, how much you will need, how much cost you will need, material, labor, and so on and so forth. Okay, so you based on your detailed design, you will go for a construction plan. Then from construction plan, you start the construction, the actual construction work. Okay. During the construction, you will do testing as well. Testing happens when? During construction. You have concrete strength tests, you have surveys about the height of the building and the layout and everything. So this is all under testing. I told you testing is where? In the field. Okay. This is done on paper. This is done in the field. Okay. So now construction work has started. When construction starts, your testing also starts. Okay. And during the construction, you start allocating the resources. Okay. So until now you are planning. I need excavator on this day. I need labor on this day. I need material on this day. So during construction, now you will start to bring all these things, right? Okay. So this is called as commissioning. If you see in the slide, this is called as commissioning. So testing and commissioning happens during the construction according to whatever you have decided. Then we have the operation and maintenance. Construction finished, project is ready. Okay, construction has finished, now project is ready. Now you have to make sure that the project maintains the performance for a long time. Right? The project maintains the performance for a long time. Okay, so if you are talking about a road, so when you construct the road for the first time, it's very smooth, everything is new, the paint is new, there are no cracks, no holes, nothing. Okay, the surface is top quality, you can go at very high speed and so on. Okay, after a few days it will start to deteriorate. Okay, some cracks will happen, the paint will go off. Okay, some of the side furniture will start damaging. Okay, now if you don't do proper maintenance, the performance of the road will start decreasing, right? Okay, people will not be able to go at the speed which you designed for. Got it? Clear now? Okay, same thing happened in the building as well. Okay, you can look at one of the things, right? This is not working, right? The project, not the roof. The project. It's not working, right? Okay. So what is it affecting? Nothing. Huh? Your lecture. Thank God he said my lecture. He didn't say your lecture. Doesn't affect me. Yes, our lecture. Got it? Fair enough. Okay. So you need to have a maintenance plan to maintain the performance of the product. If you don't do proper maintenance, your performance will start to decrease. You will not reach the design life. You will not reach the design requirements. Okay. Although the structure may still remain intact. Okay. We talked about these things. Yeah. So in this process, you have to take into account safety. One of the most important elements is safety. The other one is sustainability. Okay, we already talked about it. Okay, and what else? Yeah, cost and compliance with the regulations. Okay, in this whole process, when you are starting with the problem definition up to the testing and maintenance, you have to make sure that whatever you are doing is safe, it is cost effective, it is sustainable, and it is what's the last point? It complies with the regulations and standards. Okay. If you are complying with the regulation and standards, you already take care of safety and sustainability. Regulations and standards are basically taking care of these two things: safety and sustainability, environmental sustainability. Got it? Okay. But there can be other elements which are missed in that, so you have to look at it from your side as well. Okay. So safety can be divided into two aspects. One safety is the operational safety. The building can bear the load or not. Okay, this is operational. The road can take or the bridge can take the load of the vehicles. This is operational safety. And then we have safety against specific events. Okay, for example, safety against earthquake. Okay, so that in the countries where earthquakes happen very often, they design the building so that it can remain standing even after the or during the earthquake as well. Okay, there are regions which have very low temperature. We have regions which have very high temperature, right? Okay, so if there is, because of the high temperature, how will the building behave? Okay, so yes, it can take the load now, but what will happen if the building is exposed to very high heat for a very long time? Will it remain functional or not? Okay, so we have to look at safety from both aspects. Safety, which is operational safety, and the safety which is against the environmental conditions or any other events. Then we have the durability. Okay, if something is durable, what do we mean? If I say this phone is very durable, this phone is this iPhone, not durable. Whatever phone, okay, my phone is very durable, not iPhone. Where's my phone? Okay, so durable means what? It will come with the update next month. It will force you to change the phone. It's not durable. You have yes. Yeah, long time, right? So durability is for when something is long lasting. Okay, durability is something which is long lasting. Clear? Okay, so you have to see if the building or the structure can take the same amount of load for longer times. Okay, if you have looked at you may have a car in which you may take somebody to the airport for one time, no problem. They have their 3-4 heavy bags and you put them in the car somehow and you take them, no problem. One trip, no problem. Okay, but if you start using that, there are some people who do that, right? Some workers, they do that. They use their own car for transferring construction things and bags and so on, right? Okay, you look at the condition of their car and you compare it with the condition of a normal car. So that deteriorates a lot. Okay, that car requires more maintenance than your car. What's my point? Why? Because it is under very heavy loading for a very long time. Okay, it is under very heavy loading for a very long time. That's why we go to gym, right? You can take very heavy loading for a very long time. Huh? Okay, so you can do it. Anybody who goes to the gym for the first time, he can do it. He may carry more load, or she may carry more load, I don't know, than the others who are regularly going to the gym, right? But they can do it one time. Okay, you know what happens next? Huh? All those people who are saying this, you should go to the gym every day. Okay, so this will not happen. Anyways, but you get the point, right? Okay, a structure can carry the load for one time, but it will have a different effect if the same load is imposed for a long time. It needs a different type of strength. Got it? Okay. Then we have sustainability, which deals with the environment and future. Okay, future effects on the environment. Cost effect, we already talked about it. Functionality, I talked about it. And then we have aesthetics. Aesthetics means what? Aesthetic means what? Make it beautiful. Yeah? The opposite of this one. How I wrote it. This is not aesthetic, right? The word is aesthetic, but my writing is not aesthetic. Okay? So this is why I became an engineer, not an architect. Anyways. Okay, but these are things which you consider. Then we have accessibility. Very important. Accessibility. Accessibility means what? What is meant by accessibility? What is this? What is this? What does this mean?
Like designing a villa with one door or many doors, like the most important thing.
Maybe the term white construction is the project is accessible for the workers or not.
Yeah, okay. But you got the idea, right? Accessibility means they can approach it or not. Okay, accessibility means approach. Or entry, or use, or freedom to use. Okay, so I designed this room, okay, and everything is working, the projector is working, okay, but there is no door to it. Okay, so I cannot use it, obviously. Okay, here they do a lot of planning. Okay, if they thought about a new housing project somewhere, they made a new island somewhere, and now they are doing a housing project there, they will think about, okay, how people will go there, right? So they will design the highways with it. They have a whole plan of 2050 and so on. Okay, where we are doing a new construction, where we will need new highways and so on. Okay, in Karachi it doesn't happen in this way. Okay, so when I came to Bahrain, I bought a land somewhere. Okay, and I saw that land after a few years. Like I was here, I didn't see the land. I went to that land after some years. Even at that time, I had to search where is it. Okay, and I went off from the highway, then under something and over something. Okay, like to make one trip there, I have to get my whole car messed up because there are no proper roads there. Okay, so yes, the construction or the housing is happening, but they did not think about accessibility. So if you are not doing this, your project is not economically feasible. Nobody will come there. Okay, that's why I bought the land. I don't know where is it. So accessibility is very important for buildings. Okay, and accessibility, another part of it, accessible for everybody. It is under the basic rights. Okay, especially if you are designing public spaces. University building, okay, a mall. Okay, so you need to provide accessibility for everybody, even the person who is on a wheelchair, even the person who is walking by stick, even the person who cannot go by stairs, okay, or who have little kids with them, okay, and so on. Clear? Okay, so accessibility is very important. It can affect the feasibility of the project. Okay, then we talked about environmental impact. We already talked about it. Compliance, okay, compliance to rules and regulations of the government. You have to look into the soil conditions, what type of soil you have, site conditions, sorry. What type of soil you have, what type of weather you have, what type of topography you have, okay. If you have a level ground, level terrain, the construction becomes much easier, right? The design becomes much easier. Okay, but I already gave the example of mountainous areas, right? So design and construction in mountainous areas is different. Okay, so you have to look into the site conditions as well. Okay, then utilities. Okay, if you are just looking at your project exclusively, okay, in this space I will construct a building and that's it. Okay, then your project is not finished. You have to make sure that all the utilities are also available in your project. Correct? There? Okay. So with one project you will have these extra items as well. So provision of utilities is part of the project. Got it? Clear or not? Okay. So you don't think of project as a standalone project. Then the next thing is future expansion. What normally happens in road projects, all road projects, all highway projects. when you are designing them, when you are constructing them, you keep in your mind what will happen in future. Okay, because you know the traffic demand is increasing, right? Okay, so you cannot start working from zero after 10 years or 15 years. You have to utilize the same and try to extend on it, try to expand. Instead of building a new highway, you expand the existing highway. It becomes much cheaper. So future expansion must be taken into account as well. Okay, we are not doing the group activity. I'll just go to the last couple of slides. Okay, so earlier we had talked about sustainability, and we have included sustainability in construction, sustainability with communication, sustainability with ethics, and so on. Okay, so now we are talking about how we can include sustainability in our design. Okay, so there are some basic principles which are written here, which are all related to sustainability. There are 5 of them written here. So there are 5 sustainability principles which we use in our design, which we should use in our design. The first one is related to minimizing the waste. For your information, construction industry is one of the top 3 waste producers around the world. Construction industry is one of the top 3 waste producers around the world. Okay, the waste generated by construction industry is more than 99% of the other industries. Okay, so how we can reduce the waste? They have given us 3 strategies: reduce, reuse, and recycle. Reduce is you try to use less material, so there will be less waste. Okay, reduce less material. So we are going for smarter buildings now, smarter structures. Okay, which have lower dimensions. Okay, like they are using less material. Okay, so instead of thick columns, you go for thin columns. Okay, and so on. Okay, so use less material. The other one is reuse, and the last one is recycle. What is the difference between reuse and recycle?
Reuse in the same condition.
Yes.
That have changed.
Yes. Okay. So yes, we will have some waste, but can we use this waste again somehow? Okay. So wastewater can be used for plantation, for example. Okay. Waste aggregates can be used back in some other concrete. Okay. And so on. Clear or not? Okay. The example of reuse is formwork. You know wooden formwork? They use from one place to the other place. They take the same formwork and put it somewhere else. Okay. Excavators and so on. These are all examples of reuse. Then use of renewable energy resources. What is renewable energy? Give me an example of renewable energy.
But not such as sun.
Huh?
Sun.
Sun. Even SUN. My father thinks of me as a renewable energy source. For him, SON also means renewable energy. Okay. But sun energy, wind energy, okay, even water can be used for generating power. Okay, so these are all renewable energy sources, meaning the source which is producing the energy is not consumed. So when you produce energy by coal or by petrol, so you have to burn it, right? So renewable energy is whatever you produce without burning the actual source. So wherever we can during the project and in our design, we try to utilize renewable energy sources and use equipments which require less energy. Okay, so there are equipments which need more energy and there are equipments which need less energy. Take the example of the cars. So there are cars which have 2,000 horsepower and 3,000 horsepower. Okay, so they need more energy, right? They need more fuel. And there are smaller cars which need less fuel, right? Okay, so the difference is between their fuel efficiency. Okay, so you use devices or equipments or things in your building, in your design, which need less energy. So you try to use renewable energy wherever you can, and then you try to reduce the use of energy as well. Okay, then you design for durability, meaning long term. So even if you have to spend more now, it will work for a longer time. Okay, so 1000 which will work for 20 years compared to 800 which has to be replaced by 5 years. So 800, 800, 100, you know, in 20 years you will do it 4 times. Okay, but 1000 for now, which is working for 20 years, is less costly, right? You know, over the life it is less costly, right? Okay, so then we have the life cycle impact, and this is also related to the waste. Some waste is generated during construction, and some waste is generated when the design life is finished. So building is designed for 20 years. What happens after 20 years? You will replace it, right? Okay, so you generated some waste when the building was constructed in the first 2 months. Now you will generate a lot more waste when the building is replaced. Got it? Okay, so you have to think about the replacement of the building as well, not just at the construction or not just during operation. Okay, so this is what they mean by life cycle impact. Okay, when whatever material, whatever things I am using now, what will happen when I have to discard all of it? Where will I put it? Okay, and so on and so forth. If you follow sustainable design principles in your design, then you will have less environmental impact. You will save your cost. Okay, because you are saving energy, right? So it will save your cost. You are fulfilling your social responsibility towards other people, okay, with the environmental emissions and so on and so on. It will also give you competitive advantage. Competitive means what? You will be considered better design engineer than the others who are not following these principles, because your design is more environmental friendly, more cost effective, and better for the people, better for the society. Okay, so somebody who is giving me this design is obviously better than somebody who is not doing this. Got it? Clear? So it will create a better image for yourself in front of the client. Okay, then we have the economics. I already talked about it. Anything new? Okay, only 2 new things here. Time value of money. Anybody taking economics here? Economics course, which is from the mechanical department. Anybody took that? No? Nobody? Okay. So time value of money means that 100 BD now is a very good example. So if somebody was buying fuel last year, same time, April or May last year, okay, he will get his tank full in how much? 7 BD, right? Now I know his car. Okay, but now the same person is
60.
60. 7 to
1 6.
1 6. Thank God. I told you about board of plane. Okay, so 7 BD of 1 year ago is equal to how much of now? 16. This is called time value of money. Okay, the things which I could purchase 1 year ago with X amount, I need X plus something amount to purchase the same thing. This is called as what? Time value of money. Okay, so if I give you 100 BD now, the things or the value of that money for you now is more than if I give you the same amount after 10 years. Got it? Clear? Okay, and vice versa. If something is coming to me in future, it will have less worth than if the same thing is given to me now. Right? Okay, so things lose value because of time. And then we have the risk analysis. So risk means anything which is uncertain. Anything which is uncertain. I don't know, maybe it will happen, maybe it will not happen. Like I gave the example of the earthquake, right? It may happen, may not happen. Will you change your design because of that? In Bahrain, we don't do that. We don't do earthquake design in Bahrain. But in Japan, we'll do it. Because the risk there is more. Okay? Not there, like in Japan. Okay? So, if they spend, for example, on their design $2,000 more for earthquake design, there it is justified. They have the risk. But if somebody says, I will give you earthquake design in Bahrain, and you give me 500 BT more, you will not do it. Because there is no risk for it. Correct? So when the risk increases, your cost will also increase. Okay. The last thing is the combination of economics and sustainability. Okay, so both of these things are interrelated. Okay. So you have to consider, I told you, there are costs which are non-monetary, costs which are not money, accidents, environmental impacts, and so on. These are all costs which are considered under economic impact. Okay, even the environmental impact can have economic impact as well, and this is related to sustainability. Okay, so if your project is not safe, it is environmentally not sustainable, okay, then it has the economic effects as well. Okay, so where the economic aspect will come, I already gave you the example. You are building something which will be long term, durable, it will be very safe. Okay, but right now to do that I need to put more money. Okay, or I gave you the concept of energy efficiency, right? So I can use energy efficient equipment, but those are expensive. So the equipment is expensive, but it will save cost in the long run, right? Okay, so I make extra investment of 500 BD now, but I will save 2000 BD in the next 2 years in terms of energy efficiency. Got it? Clear? Okay, so this is how sustainability and economics are interrelated. Sometimes you are looking at sustainability and you feel that cost is increasing, but if you look at long term life cycle cost, you will feel that the overall cost is less. Clear now? Okay, so this is the end of these slides, and as I mentioned, you have the